Okay, so you've set up the room, and when the students come in, you can tell them that you're doing an escape room type challenge, and that there are no further instructions. So part of this is using their initiative. There's lots of things set up around the room, but they really need to be answered in sequence for them to actually access any of the locks. So, as we said, the first thing that you will have either hidden around the room or left at the back is this sheet here. So it says this activity requires you to work as a team and use your initiative. So what we want to see from the start is people talking, communicating, so that everyone knows what's going on. Hopefully someone will pick up that this is a QR code, so they can use their phones and a QR code scanner to take a link to this, which is a song from U2 called Ultraviolet. So again, hopefully we've got some students walking around the room, and one of them may have found that you've got an ultraviolet torch. So the ultraviolet torch here is locked with a padlock, which is a 3-digit code. And again, hopefully getting them to look around the room and using their initiative, they will find that there's a question here. In the song The 12 Days of Christmas, how many presents do I receive in total? So on the whiteboards or whatever, you want them to try and work that out.
So the first gift then is the partridge in a pear tree. So that gift of one present of a partridge in a pear tree, they get on the first day and the second day, and in fact all through the period. So they get that gift 12 times during the song. Similarly, on the second day, they get 2 turtle doves. So they get those 2 turtle doves on the second day and every day thereafter, so for 11 days. And you can continue the pattern and actually work out the total number of presents received throughout the 12 days, which, if you total those all up, would give you 364 presents, which is therefore going to be the combination you require to unlock the padlock and access the UV torch.
So again, they need to figure out where the UV coded message is. But again, this should ideally be somewhere near the front, so they've got a good idea of how to find this. Now, if you just come a bit closer here, there are a number of different ways of doing this. So I'm expecting most of them to have to use the UV torch. So you can see here that the words, so we've got crib, in a, away, manger, no. So hopefully they can figure out that that's the opening lyrics to Away in a Manger, No Crib. That will tell them the order to put these sheets in. But of course, if you've got anyone in your group who can read music, then this music is actually the same, this is actually the music for Away in a Manger. So if someone is musical, they should also be able to figure out the correct order. So let's just suppose we're doing it with the ultraviolet. So this is Away. So Away in a Manger, no crib. So you can now see that you've got what's clearly an encrypted message running across here. In theory, there's a chance they might be able to crack it from there, but as we'll see later, this is a World War II code, so it would be quite impressive if they crack it. What often you might find is that a small group of the students might then break out and try to crack that. But again, using the UV light, they may have seen up here, there is another message which says additional clues. So the idea is that your group is split into 2 groups, one group possibly working on that, the second group following this sort of carousel of clues.
Santa is training his reindeer in a regular 10-sided paddock. One of the reindeer takes the path shown above, and the angle through which the reindeer turns when it reaches the fence is marked by this angle here, X. So, in effect, what we want to try and do then is find the interior angle of the shape, and then if we can find these 2 angles here, if we subtract those from the interior angle, we can find angle X. 360 over n is going to give us the exterior angle. Therefore, the interior angle is going to be 180 minus 36, which is going to give us 144. So, if this angle here is 144, we can deduce that each of these angles here are both 18 degrees. We now then can find X by taking the entire interior angle, which is going to be the same as this angle here. So 144 minus, we're going to have, because this is an isosceles triangle, both of these are going to be 18. So if we subtract 36 from those, we're going to have an answer of 108 degrees. However, we are asked to take our value of x, which was 108, and use the function here to convert it. So if x was 108, we use the function fx equals x minus 100 to give us an answer of 8. Write out your output in letters, so E, I, G, H, T. And then use the encryption below to encode your answer. So if our input is E, that's going to take us to M. So the code word then is match. And what you need to do then is look around the room to find the combination lock with letters on it and rearrange that to make match.
Up here, a letter combination lock, and once they've done that, they can access these keys. So again, they'll need to figure out what the keys are for, but eventually it should lead them to the padlock. On the padlock is a USB stick.
This question is all about arithmetic sequences and series. So hopefully from the question, the students can pick up that n equals 100, that a equals 1, and d equals 1. So using the formula for the sum of the first n terms, n over 2, 2a plus n minus 1 times d, the students should be able to figure out that the sum of the first 100 terms will be 100 over 2 times 1 plus 99 times 1, and that will give you the solution of 50-50, which is going to unlock the 4-digit combination lock.
So, we've got the answer of 50-50. So again, looking around the room, they're looking for a 4-digit combination lock. Over here, which is 50-50. Again, they've got to figure out what the key is for. This key is for the little thing here, or whatever you've got in your classroom. And hopefully they can see a fairly prominent envelope at the front there. If they open up the envelope here, this is the question.
We are told that Santa's elves are wrapping a picture frame that has one side 3 centimeters longer than the other. The area of the frame is 40 centimeters squared, and we know it has a depth of 2 centimeters, and we're asked to find the minimum amount of wrapping paper required to completely cover the frame. So here we're trying to find the surface area of the frame. We can form a quadratic equation. We know that the width times the length is going to equal 40, so x squared plus 3x minus 40 therefore is going to be equal to 0, which we can factorize to give us x plus 8 and x minus 5. So the solution there is going to be x is equal to 5, so if x is equal to 5, the length then is going to be equal to 8. And we just need there to find each of the surfaces. So we're going to have 5 times 8, which is this panel here. So we've got 2 of those, which is going to give us 80. We've then got 2 of these side panels here, which is going to be 5 times 2 times 2, which is going to be 20. And then we've got the top and the bottom panels here, which is going to be 8 times 2, and we've got 2 of those, which is going to give us 32. So in total then, the answer is going to be 132.
Having found that the answer is 132, there are no combination locks. What hopefully someone will stumble across is this envelope here, addressed to Mr. S. Claus, with an address of 132 Lapland Drive. So if they open that up, inside, in effect, they've got the code or the key to the quiz. The key to the code, sorry. So this is a 5 by 10 transposition cipher.
At some point during this activity, I would choose a couple of pupils who perhaps haven't contributed a huge amount or are looking a little bit reluctant, and just give them a quick spy school on something called a transposition cipher. And this is literally what I would do. So if you think of a phrase, so let's say James Bond is a spy. So that's the code that we want to encrypt. So the first thing you need to do is count how many letters there are. So in here, you can see there are 15. Now, 15, if you look at the factor pairs, we've got 15 and 1, 3 and 5. Now, this works better with a larger number of combinations. So I'm just going to put an X at the end of that to make it 16. So 16, the factor pairs then 16, 1, 2 and 8 and 4 by 4. So we've got more combinations, which means it's going to be harder to crack. So what I'm going to do is I'm going to take my plain text here and I'm going to write it in a 4 by 4 matrix. So what I'm going to do is write it like this. So James, so there's 4, Bonda is a spy, and then that extra X there as a placeholder. So I've used the grid. Now what I'm going to do is I'm actually going to encode the message by writing the letters down vertically. So the message I'm going to write, my secret coded message, is going to be JSDS ABIP, so going down here, MOSYENAX. Now that, you can see, looks pretty difficult to crack, unless you know that the code here is a 4 by 4 grid. So if I knew the code was 4 by 4, when I got this information, I would just write it down like this. JSDS ABIP MOSYENAX, and then I know that I could read along. So I'd say James Bond is a spy. So that is the quick spy school that I would give to a couple of students to empower them with the skills to crack the transposition cipher. This is the actual code here that they need to crack, and you can see it makes very little sense. Even if they did understand it was a transposition cipher, it might take them a while to crack it. One of the clues they received then to try and help them is the fact that it's a 5 by 10 transposition cipher, which should really aid them quite a lot. So effectively then 5 by 10, so you're going to start off HSOTE, so there's my first 5, second OCSSR, WAEFT. And what you can see then here is you're starting, as we read along, we're starting to build up words until eventually you get to something like this, and we can partition it. So, how many ways can you choose 2 presents from 6 under the tree? Which is then the final question for them to work out.
If you do all of that, you will end up with the final answer, which is 15. And if they complete that, then they can either escape the room or get a prize or whatever it is. So this is something which takes quite a lot of effort to plan. Ideally, you would want probably no more than about 12 in a group doing this. So you might want to split the class into 2 and give them 25 minutes to half an hour each, depending on how your lessons are. But the key thing is at the end as well, trying to get the students to reflect on the activity, not only on the maths, but how they assign the roles. Who took on the role of leader? How was their communication? Did the groups know what the other groups were doing? How did they allocate roles? That kind of thing. So it's a really good activity, not just for maths, but also for communication, leadership, project management, and also resilience and initiative. So hopefully that is gives you a bit more idea of how to run this activity effectively.